Chapter 4, Section 10, Alternatives to Binary Fission. Well, it turns out binary fission isn't the only game in town when it comes to microbes. Yes, binary fission, this is a balanced growth thing. This exponential 1 becomes 2, 4, 8, and so on, producing pretty much nearly identical cells. I keep referring to them as clones with each other. Well, it turns out there are other mechanisms for making new daughter cells. We can also see what is referred to as budding. Budding is an unequal cell growth process. You have one original cell and then a smaller mini-me cell will literally bud off. Where binary fission, the one cell splits in half equally, this is a way unequal process. The binary fission. One cell gets a little bit bigger, divides in half, and you have two daughter cells that are pretty much identical. You can get simple budding, where a small little protrusion of the cell gets bigger and bigger and then breaks off. Here the artist drew it so that the two daughter cells, after this breaks off, look the same. Chances are this little protrusion that's going to break off, bud off, is going to be much smaller than the original for a while, but given time it will increase in size. Then you get budding from, say, a hyphal extension. This, bacterium will protrude out part of its cell envelope. And the end of the protrusion will form a knob, and that knob will break off and will become a new cell that will increase in size until it matches the size and volume of the original cell. You see variations of this unequal / budding thing occurring. Whether it's hyphae, mycelia, sometimes it's arthrospores. Okay, arthrospores, as we see here from streptomyces, the long cell of the bacterial cell will elongate, and then you can start to see hyphae starting to form here. Boom, 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 boom. And then each of those will break off and become a new cell that will increase in length. Arthrospores.